Hello, welcome back to Learn Physics. In today's topic, we are going to discuss about the kinematics portion, that is motion in one dimension and two dimension. Motion in a straight line as well as motion in a plane. Okay, both chapters together we will be discussing as the next one. Okay, so as I told before, this is some previous year question papers from the state board syllabus. Okay, so because I know most of you would have finished the CBSE 11th exams and all, now only that state syllabus will be pending, and for those children, if it is useful, you try this. Okay, so here the first question is, a stone is thrown with the help of a sling with initial velocity v at an angle theta from the horizontal. So what working of a sling is based on dash law of vector addition. So sling is given like this. Okay, so from here like this, and here force from here, this is moving like this. Okay, so this is as per which law? So here force is acting here, force is acting here, and then it will be what will be the force? A stone is thrown with the help of a sling with initial velocity v at an angle theta from the horizontal. So it is giving an angle theta with the horizontal. So working of a sling is based on the law of, so here force will be acting here, force will be acting in this direction, isn't it? So working of the sling, the stone will move forward. So the force will be acting in this direction, F2 will be acting in this direction from the same point. If two vectors starting from the same point, then how we will be finding out which law of vector addition we can use it over here? It will be parallelogram law of vector addition. If two vectors starting from the same point, okay, then the resultant vector will be the diagonal of the parallelogram, which is starting from the same point. So this will be the resultant vector. Okay, so this is based on the principle, which law of vector addition? Parallelogram law of vector addition. Next is, with the help of a vector diagram, state this law. So if A and B are two vectors starting from the same point, having magnitude and direction, then the resultant vector will be the diagonal of the parallelogram starting from the same point. Okay, so the resultant vector, then magnitude and direction will be the diagonal of the parallelogram starting from the same point. Okay, so this is law of vector addition, parallelogram law of vector addition. So next is, derive the expression for maximum height reached by the stone. Maximum height reached, how we can find out? See, the stone is thrown from here, it will go and come back. So it is a projectile motion. So how we can find out the maximum height in the case of projectile motion? Distance covered, initial velocity, final velocity is 0. Final velocity is 0. Initial velocity, which one we should consider? Since it is the vertical motion, and we should consider that direction only, isn't it? So if this is theta, this will be u cos theta, and this is u sin theta. Then, so initial velocity is there, final velocity is there, distance you should find out. Acceleration will be equal to minus g. Then you can find out the maximum height, and you will get it as, see, v square minus u square equals 2as. So minus u square sin square theta equals minus 2g into maximum height h. Okay, so here negative and negative will get cancelled. H is equal to u square sin square theta divided by 2g. Okay, this is the formula. This is how we will be finding out the maximum height of a projectile. So this is a projectile motion. Since the stone is thrown from a particular point, it will go to the maximum height and come back, isn't it? So it is a projectile. So you should write down this formula and derive. Okay, so next question, a position time graph of a body is given. So position time graph. See, this is time in second and this is position x in meters. Okay, 0, 1, 2, 3, 4. This is 10, 15, sorry, 5, 10, 15. 5, 10, 15, 20, 25, 30, 35. So here 30. Next is 35 also there, 40 also there. So variation is coming like this, 0 to this one, it's constant, till 40 it is, then it is constant like this. Okay, so to 30 it is coming for 3. Okay, this is the diagram which is given in the question. Okay, position time graph of 30, 35, 40. Okay, position time graph of is given like this. Estimate the velocity during the time interval from t equals 2 seconds to t equals 3 seconds. T equals 2 seconds to t equals 3 seconds. What will be the velocity? From the position time graph, how we can find out the velocity? Yes, position time velocity equals slope of position time graph. How we can find out the position, the slope of that one? T equals 2 equals to t equals 3 seconds. So here t equals 2 seconds while you are 2 is 30. Okay, so 2 till here it is coming. So while I am drawing here, from the printed one, slight changes will be there in the graph, but the values which I marked is same only. Okay, so t equals, including 2 and 3, you can draw a small triangle. Okay, so this is the first position, right? So t equals 2, this is t1, this is t2. Corresponding to t1, what is x1? This is x1, and t2, this is x2. So slope of the graph we can find out as y2 minus y1 divided by x2 minus x1. So what is the y coordinate over here? Position. So x2 minus x1 divided by t2 minus t1. Difference in position divided by difference in time. Okay, so difference in position is 30 minus 10 divided by 3 minus 2. So it is 20 meter per second. Okay, clear? So this is the formula to find out this is how we will be finding out the velocity if position time graph is given. Position time graph is given means you should find out the slope of position time graph to find out the velocity. Okay, clear? Next is displacement of an object is proportional to t cube. Show that acceleration is increasing with respect to time. So displacement is t cube. How we can find out the acceleration? They are not telling you to find out the acceleration. It is proportional to time. Acceleration is proportional to time. So if whether it is proportional or not, to find out that, what we should do? First we should find out acceleration, right? So position is given as t cube. First we can find out the velocity. How we can find out the velocity? V equals dx by dt. So d by dt of t cube we should do, because x is t cube, right? So t cube we should do. Now velocity d by dt of t cube. How we can find out? D by dx of x to the power n as n into x to the power n minus 1. This is the differential equation. Okay, n into x to the power n minus 1. So while we are using that one over here, v equals x to the power n. Here it is 3. So 3 into t to the power 3 minus 1. So we are getting it as 3t square. This is the velocity. How we can find out acceleration? Acceleration will be equal to dv by dt. So 3 into 2t, that is 6t. That means acceleration equals a constant into t. That means acceleration is proportional to time. Okay, clear? This is how we will solve this equation. Next is Velocity is defined as the rate of change of displacement. Distinguish between average velocity and instantaneous velocity. Average velocity means total distance traveled divided by total time. That is average velocity. And instantaneous velocity is velocity at a particular instant of time. How we will represent instantaneous velocity? Instantaneous velocity equals limit delta t tends to 0. That means time interval is very small. Delta t tends to 0, delta x by delta t. This is called as dx by dt. This is called instantaneous velocity. Velocity at a particular instant of time. Okay. So the next one is, when does average velocity becomes equal to the instantaneous velocity? See, when they are in uniform motion. If the object is under uniform motion, instantaneous velocity will be equal to average velocity. Okay, so instantaneous velocity, when does average velocity becomes equal to instantaneous velocity? If the object is under uniform motion. That means what is meant by uniform motion? Uniform motion is if for a particular interval of time, if the distance covered is same. Okay, in an interval of time while we are considering, for every 1 second, suppose if I am considering the distance covered by the object is same, then we can say the object is under uniform motion. If the object is under uniform motion, average velocity will be equal to instantaneous velocity. So each one, see if it is 1 to see 40, distance covered is same. So if I am finding out the average distance, means how much I will be getting? 40 only average we will be getting, right? So the same way, so time interval anyway same only. So you will be, if both are under, but in between, see 45 or 42, like that it is coming, we can't predict. We should do and find out, right? What is the average? So when uniform velocity, this instantaneous velocity becomes equal to average velocity when they are in uniform motion. Okay. So the next one is, a car travels from A to B at 60 km per hour and returns from A to B at 90 km per hour. What is its average velocity and average speed? So from A to B, it is moving with a velocity of 60 km per hour. B to A, it is moving with a velocity of 90 km per hour. Okay, so what will be the average velocity? Average velocity means it is the total displacement divided by total time, right? Total displacement divided by total time. Here what is the displacement which has happened over here? What is the initial position? A is the initial position. Now what is the final position? A itself. So what will be the average velocity? Average velocity will be equal to 0. Then how we can find out the average speed? Average speed equals total distance covered divided by total time. Okay, so we should find out the average speed by calculating the total speed and total time. But we have only the velocity with us from A to B and B to A. Okay, here this A is the position here, this is the B. Let x be the distance between A and B. Okay, from A to B is given as 60 km per hour. Okay, then this one convert it into this meter per second or 60 km per hour, like that itself you can do. It's not an issue. If you want you can change, that's all. Okay, so I am doing it like kilometer per hour only. Next, velocity from B to A is given as 90 km per hour. We know velocity equals distance traveled divided by time. Speed equals distance traveled divided by time. So we can write it as x divided by t1. Okay, distance is same. So from here to here it is taking t1 time, and here to here it is taking t2 time. So here x by t1. Here same way we can write down same distance only it has covered, x by t2. Okay, so what is t1 from here? X by 60 and r, and t2 equals x by 90 hours. Okay, so what will be the total time? t1 plus t2. So x by 60 plus x by 90. Okay, so next, so what is the, now we can apply in this formula. What is the average speed? Average speed equals total distance covered. What is the total x distance forward and x distance backward? So total distance is 2x divided by total time is x by 60 plus x by 90. So here numerator, denominator x is there. You can cancel that x. So here x and x will get cancelled. You will get it as 2 by 1 by 60 plus 1 by 90. So 60 into 90 if I am considering, 2 into 60 into 90 divided by 150. So 0, 0 will get cancelled. 3 3s and 3 5s. 12 5s are here. So here we will get the answer as 72 kilometer per hour. Like that we will get. Okay, clear? Next is a projectile is a particle which is projected into air with an initial velocity against gravity. What is the angle of projection for maximum horizontal range? So for that you should know about what is the formula for R. R is equal to u square sine 2 theta divided by 2g. Okay, so what will be the maximum when we will be getting R maximum? R maximum we will be getting it as, see here u is initial velocity will be constant, g also will be constant. So R maximum we will get when sine 2 theta is maximum. When sine 2 theta will become maximum, what is the maximum value of sine theta? Is 1. Okay, then what will be 2 theta? 2 theta will be 90 degree. Then what is theta here? It will be 90 divided by 2, that is 45 degree. So for at an angle of 45 degree, it will be getting the maximum range. Range you know, right? What is the starting point? From that point, the same horizontal distance when it is reaching, the distance covered in this horizontal distance is called as range. Range of a projectile. Okay, clear? So the next one is draw a trajectory of a projectile, obtain the expression for time of flight. Okay, trajectory like this only. This is u. Okay, each one you can represent this as u, and here this will be u like this. This is theta, and u, if we are dividing it into components, the component which is coming near to theta will be cos component, u cos theta, and this will be u sin theta. Okay, acceleration upward direction we can consider it as minus g. Okay, this is the representation of this what is that, acceleration, projectile motion representation. Obtain the expression for time of flight. How you will find out the time of flight expression? See here, till here exactly half. What is the time? That time interval first you should find out. Okay, then twice that one will be giving you the total time of flight. So that formula, while you are finding out the half of the time, then you will get it as u sin theta divided by g. So the total time you can write it as 2u sin theta divided by g. Okay, so clear? So this is how this one you should derive. Okay, the derivation of v is equal to u plus at. That using that formula you can find out the value of t, small t. First you find out the value of small t, and then find out just multiply with 2. Okay, so this one already we did in our previous videos. So yes, if you have any doubt you can just go through that. Okay, so next is uniform circular motion is a special case of two-dimensional motion having centripetal acceleration. Define centripetal acceleration. acceleration of an object which is acting towards the center of the circle. That is, an object, if it is under it is under circular motion, the acceleration which is acting towards the center is called the centripetal acceleration. Can a body have acceleration with a constant speed? Yes, in circular motion while it is moving, it is having a constant speed, uniform circular motion. If an object is under uniform circular motion, this it will be having speed will be same, but direction of velocity will be changing with respect to the tangent. Okay, it will be changing as per tangent. So speed will be same, but acceleration will be present over there. Okay, because direction is changing, right? So it will be having acceleration. So can a body have acceleration with constant speed? Yes. Explanation is like this. If an object is under uniform circular motion, it will be having constant speed, but the direction is changing with respect to its tangent. According to the tangents, direction will be changing. Therefore, velocity will be changing according to that. Therefore, the acceleration is present. Okay. Next is express angular velocity in terms of angular displacement. Angular velocity is omega. Angular velocity omega equals d theta divided by dt. Theta is the angular displacement. Unit is radians per second. So is it clear for you? And in next day also I will be continuing with the same topic only, same chapter, previous year question paper we will be discussing. I think it is clear, whichever this is not very hard and all, it's simple only, but if you know the formula and all, then only you can write down it properly. Okay, don't forget to write down and study about the derivation part. Okay, so if it is clear for you and if you like the channel, please don't forget to subscribe. Thank you for watching. Bye.